The course that I have been teaching in the past 2 semesters is parallel programming and problem solving using CUDA. The traditional way of scaling performance by having higher clock frequency is running out of steam because they all have hit the power limitation in these designs. It's no longer practical for manufacturers to turn out faster single-core processors. And so they all have to switch to the multi-core in order to have continued increase of performance into the future. All of them will come with multiple processor cores, and all of them will require parallel programming. And unfortunately, from computer science as a discipline, we have not educated students to do parallel programming and make good use of all this hardware. The complexity and difficulty level of parallel computing is a lot higher than the sequential computing. In many ways, CUDA is actually simplifying parallel computing and parallel computing education. The reason is the CUDA model is a data parallel model, and data parallel model tend to be the simplest form of thinking in parallel. The idea is, when you have a very large amount of data, you can have parallel execution units, each focusing on a portion of your data. And that tend to be a very simple concept for students to grasp. It essentially gives a template to the students. When they follow this template, they can actually organize their data and execution in a way that will be more likely to succeed. It's actually a lot easier for students to begin to understand these concepts and manage that complexity. The GPUs allow us to reap the real benefit of parallelism by executing these code in very high performance. And that has been a very difficult process for many of the parallel processing systems in the past. CUDA is really a very simple solution to a daunting, complex problem. These GPUs are a big step forward because they make that whole process a lot easier. We want to be able to contribute to the big advances and breakthroughs in parallel computing.